Welcome back, learners. As you know, in the previous lecture we have discussed about the application of the dead loads on the problem that we have taken. As I already told, IS 875 part 1 will be an IS code that we are supposed to follow in order to apply the live dead loads. So this IS 875 part 1 will give you the different types of materials that you use for the construction. With the help of that different types of materials, so it will give you the data of unit weight of the material in kilonewton per meter cube. Unit weight of the material in kilonewton per meter cube. So once you get the unit weight of the material in kilonewton per meter cube, usually based on the thickness of your wall that you are providing and the height of the wall that you are providing, as we discussed, we have to convert that into uniformly distributed load and we have to apply it on the beams. Okay, you have to apply it on the beams. So usually we apply the wall loads directly on the beams. Okay, we apply the wall loads directly on the beams. And when it comes to the self weight of the beam, column and slab, so the software itself will directly take it into consideration while doing the analysis of the structure. So therefore, no need to apply separately the loads of the slab or the loads of the column or loads of the beam by converting it into the kilonewton per meter using the density of the concrete. Usually we take it as 23 to 25 kilonewton per meter cube. By converting that into kilonewton per meter, so it is not required to convert it into the UDL and applying it on the beams. So the software will automatically consider the self weight. That's the reason we define the live load as well as dead load, both the loads in the load cases. Now, when it comes to the application of the live loads, okay, so when it comes to the application of the live loads, 875 part 2, okay, 875 part 2 will give, or we are using that IS code in order to select the live loads of the building. Okay, in order to select the live loads of the building. So the 875 part 2, when you go into 875 part 2, so it will be having the number of types of buildings, right? For example, residential buildings. In the residential buildings also you will be having so many types of categories of the residential building. And then when it comes to the public buildings or the commercial buildings, so there you have all different types, like the public buildings with the office is different, with the school is different, with the hospital is different, okay, with the commercial complex is different, with any malls and cinema theaters is different. Okay, so like this various public buildings and that commercial buildings are there. So then industrial buildings is different. So like that, if you go to 875 part 2, so you will get n number of information where that will give you the live load that you have to consider. Okay, that will give you the live load that you are supposed to consider for the design. Now according to that, typically if I take any one residential building, whether it is an 1-story or 2-story, and whatever the information that 875 part 2 will give you, it will be for each floor. It is not for the entire structure. You have to consider it for the each floor. Okay, so when you have a normal residential building, okay, a normal residential building, usually the live load that we consider, okay, assuming that no any other kinds of loads are acting, okay, no any other kinds of loads are acting, the usual normal live load that we consider for the design, okay, that we consider for the design is usually 3 kilonewton per meter square. It is a floor load it is not an uniformly distributed load, it is a floor load. Therefore, usually the value of the live load that we take for your residential building will be 3 kilonewton per meter square. Okay, it is an area load or the floor load that we have to apply it on the slab. And keep it in mind, student, when it is applied on the slab, the ETABS software will automatically convert that floor load and it will consider the load whatever the proportion that will come to the beam. Okay, whatever the proportion that will come to the beam, so that will be automatically, it will be taken care by the software. For example, what I am telling is, when it comes to the load distribution of the slabs to the beams, we have usually two types. Okay, for example, when I take a rectangular slab like this, okay, when I take a rectangular slab like this, there are two ways of the distributions of the loads. Okay, so the one way is the one type of distribution of the loads is this one, what we call it as triangular loading. Okay, it means if the load is acting here, okay, so if the load is acting on the slab at an of 3 kilonewton per meter square, so the load, the transfer to this particular beam will be of this much area. The load transfer to this will be of this much area. The load transfer to this on this beam will be this much area, and the load transfer to this beam will be this much area. This is possible when you have an one-way slab. Okay, this type of loading occurs when you have a one-way slab. When you are doing the manual design, so you have to consider, for example, if you are manually designing a beam, so you are supposed to consider the loadings like this. You have to calculate, okay, you have to calculate the area, okay, you have to calculate the area of this. After calculating the area, so you convert them to per meter, so you will get an UDL that you can apply on this beam. Similarly, you calculate this area, you convert into, it will be in kilonewton per meter square, convert it into the kilonewton per meter, so that will be the load that it will, this beam will receive. Similarly, you convert the area, so that will give you the load that this beam receives. And you convert the area, that will give the load that this beam receives. Okay, that this beam receives. So in this way, this is possible when you have the one-way slab. Okay, when you have one-way slab. Okay, when you have the one-way slab, this is how the load distribution takes place from slab to beam. So when you have the two-way slab, okay, so when you have the two-way slab, the distribution will be like this. Okay, so when you have the two-way slab, the distribution of the load will be like this, right? So this will be the trapezoidal shape, this will be the triangular shape. So on this beam, this much area of the load will be transferred to this beam. So this much area of the load will be transferred to this beam, this much area of the load will transfer to this beam, this much area of the load will be transferred to this beam. So this is how it happens in case of two-way slab. Okay, So this is what it happens in two-way slab. So when you are designing manually, so you have to calculate the load on the beam in this manner. Okay, you have to calculate load on the beam this manner. But when it comes to ETABS software, learners, the software will automatically convert the floor load what you apply on the slab in this manner, and the beam will be designed. So based on the Ly and Lx, that is longer and shorter dimension of the slab that what we have modeled, so it will be decided as one-way and two-way slab. So after deciding one-way and two-way slab, automatically, so the load conversion from kilonewton per meter square to kilonewton per meter will happen, and it will be considered in the design as well as the analysis of the beams. Okay, yes. So now according to that, usually we will consider the live load on the slabs equal to 3 kilonewton per meter square. But when you go to the roof, okay, for example, now here there is no slab at all because it is a ground level, so the soil will be present. There is no any application of the live load. Okay, there is no any application of the live load. But when it comes to this slab, there will be an application of the live load. So that live load application is equal to 3 kilonewton per meter square. But when it comes to your roof, as per the IS 875 part 2, whatever the live load you take on the floor, half of the live load will be usually taken it as on the roof. Why is it so? Usually this is not the area of living. So usually sometimes few people, so during the evening or during the morning time, so just they come over here. It is not a space of utility. Okay, it is not a space of utility where no people will live here. Okay, so it means there is no any regular flow of people, or there is no any regular flow of load. Okay, so only sometimes, and there is no any furnitures or any other instruments, nothing, since it is not an habitat area. So the load on these slabs will be much more smaller compared to load on this first floor slab. Here definitely the people stay, it is an habitat area, so definitely there will always be a moment of loads. So therefore it will be taken it as 3 kilonewton per meter. So only half of the load will be considered to be on the safer side. Even though that 1.5 kilonewton per meter also it will not act, but to be on the safer side, sometimes due to some functions organized in the home, so you may utilize this area, so where all people can accumulate. So in such case, okay, so to be on the safer side, so even here we will consider an area of and load of 1.5 kilonewton per meter square. This is about live load. But when it comes to the slab, along with the self weight of the slab and along with the live load on the slab, an additional load of 1 kilonewton per meter has to be considered, which is called as floor finish load. Because when you come here, so slab will be there, above the slab you will be using the floor finish. It may be made up of tiles, vitrified tiles, it may be made up of wooden flooring, you may have the mosaic flooring, you may have the marble flooring, so you may have any type of flooring, right? So usually that additional loading will be considered as a dead load whose value is equal to 1 kilonewton per meter square. So therefore what we have to do when it comes to the application of the load on the slab, in the previous lecture we have seen the application of the load on the beams. Okay, so whereas when it comes to the application of the load on the slab, the first load that you have to apply is a dead load of 1 kilonewton per meter square on both this floor as well as this floor. Then you have to apply a 3 kilonewton per meter square live load on the first floor and 1.5 kilonewton per meter square on the top floor. Okay, so now let us apply that, how to apply this. So here I will be applying one story by one story. So therefore first what I'll do, I'll keep it in plan. Okay, so I'll go to first floor. Okay, I'll go to first floor here. Yes, yeah. So now what I have to do, first let me apply the dead load of 1 kilonewton per meter, that is floor finish, on all the slabs. So therefore what I'll do, I'll just select all the slabs like this. Okay, I'll select the slabs. Yes, so I have selected the slab. Now what you have to do, you have to go to assign. Now in the previous lecture, when I go to the assign and I want to apply the load on the beam, therefore I went to frame load. But here I have to apply the load on the slab, therefore I have to go to shell load. When I go to shell load, then again you will have the three options: uniform load sets, uniform, non-uniform and temperature. Here whatever I am applying, that is 1 kilonewton per meter square, or live load of 3 kilonewton per meter square, or roof load of 1.5 kilonewton per meter square, they are all uniform. Okay, it will be uniform per meter square, therefore I can directly choose uniform. So in that, first I am applying the dead load on the slab of 1 kilonewton per meter square. So therefore I will choose the dead load. What is my load value? It is 1 lb per meter square. Okay, so when I convert it of 1 kilonewton, just a minute students, so let us see if I convert what will be the value. Okay, yeah. So when I want, yeah, so if I want to convert 1.5 kilonewton per meter square to pound to square feet, I have to apply around 32 pound per square feet. Okay, 32 pound per square feet. Okay, yes, that is how you are supposed to convert. Just a minute. Yeah, it will be almost 30. Okay, so therefore I have to apply 30 here, and definitely it will be in the gravity direction, so I will give apply. Okay, I will give apply. So therefore you can see, so the load of 30 pounds per square feet is applied on all the slabs. Similarly, I will go to the next floor. So there also I am supposed to select the slabs. Okay, there also I am supposed to select the slabs. Here again I will go to assign. I'll go to shell loads, there I'll go to uniform, there also dead, apply, right. So therefore if you see it in 3D, so on this floor as well as on this floor I applied the dead load. Okay, I applied the dead load on the slab of 30 lb per square feet or 1.5 kilonewton per meter square. Then now I have to apply the live load, right. So for that what I will do, I will go to first story, that is here, then again I will select the slabs, again I will select the slabs. So once the slabs is selected, now I will go to assign, I will go to shell loads, I will go to uniform, but there from dead I will go to live, there from dead I will go to live. So there I have to make it to, it is 3 kilonewton per meter square, I have to convert into pounds per square feet. So that means it is almost 60. Okay, so almost 60. Okay, I have to give the value 60. Then I'll apply, right. I'll apply. So therefore, so a 60 kilonewton is applied everywhere here. Now I'll go to the top floor, that is at the top, as I already told, there only 1.5 kilonewton meter square of the live load is enough. So therefore I will choose the slabs. After choosing the slabs like this, I will go to assign, I will go to shell loads, I will go to uniform, there I keep it live and I will apply 30, I will give apply, OK. So therefore if you see now, you can see 60 and 30 of the live loads is applied, right. So now if you want, you can check everything by showing the display. So I will go to display, I will go to load assigns. First let me check for the frame load. So when it is applied on the beams, there is no any application of live loads. So all are applied under dead only. So no live load is applied. So therefore I will give apply, I will give OK. You can see that all the dead loads on the beams is appeared. So everything is proper. Here is higher, here is here, and here it is same, here it is less, because these loads are equal to the main wall, which is of 9-inch wall and 10 feet wall, whereas this is 9-inch wall and just 3 feet wall. Okay. Then if you want to check that of the floor load, so first I will go to load assigns, I will go to shell. So in that shell, first let us check all the dead loads which are acting on the slab. Therefore I will give dead, I will give apply. Now you can see here 30, here 30, that is floor finished load. Now when I make it to live and when I give apply, so now you can see it is 60, it is 30, that is live loads. So it means my all the live loads as well as dead loads has been assigned. Okay, my all the live loads and dead loads has been assigned, right. Yes. So once this is done, so before the application of, before we do the analysis, in the previous lecture itself we have seen that before analysis the diaphragm has to be applied. Okay, the diaphragm has to be applied without fail, right. The diaphragm has to be applied without fail, right. Yes. So how we have to apply the diaphragm? You can see here, you can keep it in plan. Okay, apply. So select the entire structure, right. Then go to assign. Okay. Yes, go to assign, go to frame, and in the frame so go to go to assign, go to joint, in the joint go to diaphragm. So select D1, then you apply it. Okay. So therefore your diaphragm is also applied on the slabs. So once the diaphragm is applied, so then you have to analyze the structure. how we have to analyze? See here, you can see analyze. Okay, so before you go to analyze, usually you can give an option called as check analysis. So what is this check analysis? So when you give for the check analysis, so it will check and it will tell you that is there any mistakes. For example, if there is any overlapping of members, or if some values has been defined, for example grade of concrete, but it has not been assigned to some members, by mistakenly you have left that members. Okay, it means some unused values are present, means, so then it will give you the warning. Or if joints are not properly connected somewhere, so if there is any mismatches, then it will give you the warning and it will show where the mistake is. So if any mistake is there, it will give you the commands. If no mistakes are there, then it will say okay, everything is okay, then you can run the analysis. So let us just check the model. Okay, you can check the model for everything. Joints check, joints bar joints within the tolerance, joints are frame within the tolerance. Okay, then joints are shell within the tolerance, then frame overlaps if it is there, frame intersections within the tolerance, frame intersections within the area edges, if there is any shell overlaps, then any other meshing issues, everything you can see. Okay, yes. So once this check, if you select it, you can see that it is checking. Okay, you can see model has been checked, no warning messages are generated. It means your modeling is proper, everything is okay. If there is any mistake, in this warning box it will show you what is the mistake. Okay, it will show you what is the mistake. So in this there is no any issues, so everything is proper. So once it is checked, then what you can do, you can go for run analysis. You can see when it is running, it will be showing what is the procedure it is going on. Okay, what is the procedure it is going on. So once the analysis is done, there will be a deformation change in the shape of the building. Okay, so there will be a deformation change in the shape of the building. Okay, so that how it is going to change. Okay, so that everything, it will take some time. Okay, so that how to analyze it properly after analyzing, so how the structure is going to change, how to, what are the results that we are going to see, that everything we will see in the next video. Thank you, learners.